before we start, a little bit of history about Akka persistence. So it started a long time ago. It was an extension, not built by the Akka team. It was created by a guy called Martin Krasser, and he created an extension called EventSourced. And the goal was to take the state of an actor and persist the state in the form of events that you could replay and reconstruct the state of an actor. That was the goal. So I would say that's the right side of a CQRS thing. So CQRS, what I was talking about CQRS and someone, and the audience asked, well, you said CQRS already 5 times, but I don't know what CQRS is. So CQRS is command query responsibility segregation, and CQRS. And the idea is that you have, from one side, you have a write mode where you send commands. Those commands will create events in some sort of journal that you can then replay the events to recreate your state. That's the command side. And on the other side, you can read those same events to generate views of what we call the read side. But the goal here was to have event sourced. It was not to build CQRS applications for Akka. It was just to have the state of an actor event sourced, that we could play persist events and replay it to reconstruct that state. Later in Akka 2.4, it became part of Akka, and we started to call it Akka persistence. So it was not a third-part library or extension anymore, but it was a Akka, still an extension, but built by the Akka team. There was at that time something called persistence view, and it was a try to have the read side of a CQRS. It was not yet what we needed, but I don't remember if it was already introduced when it was still event sourced, or if it was introduced when it became part of Akka, but was not the right abstraction. So later in Akka 2.5, they introduced Akka persistence query, is where like an API where you can query the journals and say, okay, give me all the events for this entity, or give me all the events tagged with this tag, so you can read it and generate data from that. That was all based on general Akka actors. So we have to, in Akka, the previous Akka before 2.6, you have an actor and have to, instead of extend an actor, you have to extend a persistent actor, and then you get the API that you could use. But it was an API that you could actually do anything you want, eventually not in the right order as well, and you could break your actor if you don't pay attention. So in Akka persistence typed, we have not only a typed API that we're going to see, like typed actors, but now Akka persistence typed API, but it's also a more restricted API in the sense that it puts the rails where you have to code inside those rails, and you cannot shoot yourself in the foot anymore. So let's see how it looks like. So that's important. I had this slide because when I start to give that presentation, I was using milestone and release candidates, and the code could change in between. I was like, watch out, what I show here is not what we're gonna download tomorrow. But it's okay now, it's stable. It's already 2.6.1, there is a one bug fix release in between. So now it's Akka Typed. I will just briefly talk about Akka Typed, not yet Akka persistence typed. So in Akka, who is familiar with Akka, really familiar, have built stuff with Akka? Okay, half of the group, the rest start tomorrow, okay? So tomorrow is Saturday. Yeah, start tomorrow. They pay you well here. No, I cannot say that. They will tell me that I'm forcing Lunatech employees to work on the weekend. It's not true. So in Akka Untyped, you could send a message to an actor, that any kind of message. You can send a string, you can send an int, you can send the types that you define for the message for this actor. In Akka Typed, you have to define what we can call a protocol, how you're going to talk with this actor. So here I'm defining a trait, call it message, and I have say hello and change greeting. That's it. And the actor that I will create, I can only send message to this actor of this type message. It can be say hello or change greeting. If you were on Eric's talk, he was saying that there are two ways of building Akka Typed actors, the functional one, the more object-oriented one. I will show the functional one because it's the coolest, and also because the Akka Typed for persistence is only functional one. Akka persistence typed for, yeah, I don't remember what I said, but the function, it's a better one. Well, more interesting, I would say. Let me change like that. So what we are doing here is creating a behavior. And different than Akka Untyped, you don't extend an actor, but you define a function. And that function, the kind of function we're going to define here is a behavior, and it's basically a function from the type of message that I can send. In our case here, it's called message for lack of creativity from myself. And here you define how you're going to handle that. There's the case, say hello, I will just print something and I will return the same behavior. So basically it's a function from the incoming message to the next behavior. And in that transition that you go from one behavior to the other, you do some stuff. You do some side effect or some work, whatever you need. So in that case, I just print something and I return the same behavior. In the other case, I will change my greeting. So you can say, instead of saying hello Lunatech, I say in Dutch, hello Lunatech. So I send change greeting with a new message here, let's say hello. And what I'm doing here, I'm doing nothing, not printing, I'm just return a new behavior. And what behavior is that? Is that same one. I'm recursively calling this one with the new greeting, returning another function here, but the state here is in the scope of my function, it's greeting. So next time that I get to say hello, say hello, that greeting here will be whatever I passed here. So basically you're just playing around with functions, and you don't have here the sender, you don't have the context, you don't have anything like in a normal actor. There are means to do that. I will show later. So you can wrap those functions in other functions to have access to more Akka stuff. One important thing for Akka persistence typed is that you, as I was saying, you don't have the sender. When you send a message to an actor, you can respond back because inside the actor, the untyped one, you have the sender, and you can send a message back to the one that sent you that message, the sender of the message you just received. But here's a function, you don't have that. And there are other reasons for not having the sender in Akka Typed that I will not go into detail, but how to do that in Akka Typed is that you need to define in your protocol that message is expecting a reply. And how you do that, I'm afraid of this cable here, in that say hello message here, now I'm passing another actor ref, that is a typed one now, and it's where I want to have my reply, okay? So I got it here, say hello, here's the reply, and I will reply back. So I'm not doing println anymore, but I'm replying back on that actor that I'm getting in my message. So I send a message, and the message that I send contains the place where I want it to be replied to. Can be myself, can be another actor. I can say, I give you that, but please reply to her, not to me. I will gonna do something else. I just give the protocol for you to start a conversation, and I am the initiator, and I will do something else. Just an example. That's important, or at least I find it important when you're doing event sourced, and we're going to cover that in a while. And that's why I want to bring that to your attention, that the reply to actor ref of R that I have here. A little bit more. So in this example here, I'm taking this reply to, but I will be calling that actor from outside the actor system. So I'm doing an ask, just that you understand what are the mechanics behind here. What's gonna happen is that I send that ask, but that say hello message now, it needs to receive, I need to have somewhere an actor ref of hello. But I don't have it. I'm outside, I don't have an actor. So the ask pattern now in Akka Typed, it will build for you that reply to. By type inference, it will know that this reply to will be of that type. So it will synthesize an actor ref for you for that type at compile time, but this is a special one. When that actor here receives the hello message in its mailbox, it will take that message and it will complete a promise that will complete a future, which is that one. And now I got that hello message here that goes via this actor ref outside the actor system inside the future. So this, when you do this ask, we synthesize an actor ref for you where you can send your reply that will complete the future that is outside. So that's how it will work when you are calling the ask from outside. When you are inside an actor and you do an ask, you don't have that. You have either pass yourself and you say, you send the reply to me, and where the reply will go just go to your mailbox, will not complete a future. We are just communicating between two actors, and one will put message in the mailbox of the other. When you are outside, there is this small trick that you're gonna put a message, the hello reply, in the mailbox of this actor, but Akka will automatically take that message and complete that future for you because you are outside of the actor system. So that's that existed already in Akka Untyped. That is how it was working before, but now you need the types. And because you need the types, we need to synthesize that the ask now receives a function from actor ref of hello to your message. Okay, that's everything that I will talk about Akka Typed here. Now Akka Persistence Typed. Ta-da! Where are my slides? Here. So we will talk about protocol, the message, but for persistence you need a little bit more. You need the commands, the events, and the state, and you have to encode it. So your protocol is a little bit more extended. And you're not going to define a behavior, but you're going to define an event-sourced behavior. Remember that initially the name of the library was EventSourced, and then it became Akka Persistence. We still call it Akka Persistence, but now we don't have a persistent actor, you have an event-sourced behavior. Because actually that's the sense of what it's doing. It's doing event sourcing for your actor. In that case now, a bit for your behavior. That existed already a tagging function, and I'll explain why you need that. And it changed a little bit in the new version. You have a better control of snapshotting, and I explain how and why it became better. Enforced replies, which is my preferred feature actually, and I have a demo for that because I prefer to explain that showing code. Important is the existing Akka Persistence plugin doesn't change. What's changed here is the high-level API, the user-facing API. The underneath plugins architecture is exactly the same. So if you are using Cassandra of the JDBC plugin or any other plugin, you keep using it. It doesn't matter. And then people ask, and about the query. So that's the right side, that's creating events and sending commands and persisting events. The query side was already typed because it's based on Akka streams. When you ask for events from some entity, you get a source back, a source of those events already typed to just consume it. So there is no change there. So it was already typed, I would say. Okay. How it looks like, so you start to define your commands and events. Actually, I should say commands, replies, events, and state, because the replies are also part of your protocol that we're going to see in a while. Well, we can see here already. So I have a very simplified account model. That's my state. I have a balance. You can send commands deposit and withdraw. You can get a balance in which I have encoded in my types the kind of communication that I want. I send a message, I want a reply here, and the reply is balanced. And those are the events. This one will not persist events. I would say it's a read-only command. I'm fetching data, while those two here, I'm deposit and withdraw will produce data. So that is the types of my protocol, I would say. And then I need to glue them together and put some logic. So we start by the command handler, which will be a function from state. So I have a state, I get a command, I will produce an effect. I'll tell you what is the effect in a while. In my case here, I decide to use, you can do that in a different way. The API will request you this function here, but what we're gonna do is define, and that's a choice, object-oriented style. I have a case class and a count, which is my state, and I have a method, apply command, that receives a command and returns effect. Can you see that if I model like that, I can lift that object-oriented representation to that function? I have a state, I call the method apply command, and now I can build that function. We're gonna see. So what is the effect? Effect is actually I declaratively tell Akka what it needs to do. So I'm saying the effect here will be persist. For this deposit, I want you to persist that event. If you send money, if you put a deposit on my account, I always accept. You're gonna see that withdraw, I will deny it. But you can always put money there, okay? That's the first hint, okay? There is another hint during the talk. So I will show the rest in a while. That's the command handler. It just emit events or persist events. Next is the event handler. Again, similar function, but this time from state to event to state, in which I take my balance, I take my account, I take the event that comes in, and I will apply either deposit of withdraw, which is I change the balance of my model and I return it back. You can encode it in many different ways. I just chose here to do object-oriented style. So now I have my protocol, I have those two main functions. The previous one was not fully implemented. This one is exactly everything that I need for this model. The command handler is a little bit more, I will show later. And now I need to glue them together. And I glue them together by taking EventSourcedBehavior. And I say, my types are commands, account command, account event, and account. That's my persistence ID. I have kind of a label here of namespace. That's my initial state. I start with balance 0. And now I'm lifting my object-oriented encoding to a functional encode. I need that function here, state command to effect. Account commands, I take the account and apply the command. This apply command returns the effect. So I lift one to the other. No? And same here. So far so good. Easy, no? Yeah. Come on. So tagging. Now in Akka Typed, you had a place where you could do the event adapters, and the event adapters you put you encode there how you want to tag, but here is discoverable. I just type dots and I see what is the function that I can have. So I discover my API and the functionality. So I build my behavior by putting all the pieces one after the other. So what I will be doing here is, for deposit, I will add two kind of tags, account and deposited, and withdraw. Normally you only add one. And the reason for that is that later, when I want to consume those events to generate some views, in the read side I will say, give me all the events that are tagged with account. I put two just to show that it's actually the tagging is a set of tags. But usually you only use one tag, but it's just to show the API. That's how to tag. Tag events snapshotting. So the snapshot, if it's not clear for you, it's imagine if I have a journal for one given model, entity, account, whatever. I have 10 events. When I bring it back to memory, I will replay those 10 events. If I have 100, it's okay. But if I have 1,000, 10,000, I have to fetch them all from the database, deserialize them and apply just to process one command. So you do snapshotting to avoid this reloading from scratch. So from time to time you can say, please now save my state. Next time that I have a command, I will not replay since the first event, but since the last snapshots and the events that happen after that snapshot. So it's like an optimization. You don't need to use it like a shopping cart. How many events do you imagine a shopping cart has? Like you put a product, you put another one, you remove one, you put another one and you check out. We'll talk about four events, but a bank account, mine is not much but yours probably a lot of events there. So in Akka Typed, it was not declarative like that. It was imperative. You have to just say now I want a snapshot, and people could make a mistake to save a snapshot and then save the event, and that was wrong. You need to first have a new model, an updated model to save. So you need first to apply the event and save the snapshot. But if you save the snapshot and then you apply your event, you save the wrong snapshot. And I have seen it happen. I didn't that. It was not me. I fixed the bug. So here is different. Now in the new API, you declaratively tell when it has to happen. So here I'll say make a snapshot every 100 events and keep at most 2 of them in my storage, and start to clean up snapshots. Or using a predicate. Whenever I have an account, this kind of event, I can also check the sequence number I'm not using. I want a snapshot. Otherwise, for all the other kinds of events, I don't want a snapshot. And you can use both. Okay, so now I will show the enforced replies. Am I on the right? Okay. So I have here this account model, which is a little bit more evolved than the one that I put on the slides. All my commands have a reply to. That's also important. Even when in Akka Typed, you cannot fail a command by throwing an exception, because you need to have a type to return to respond to the actor. So basically, it's here on top. I have defined here an account reply, and there are a few types. There is the balance. I can reply with the balance or with a confirmation. And the confirmation can be I accept it or I reject it. So you cannot throw an exception. If you throw an exception and you are outside waiting for this feature to complete, it will not complete. You will have a timeout. Your actor will die there and your feature will time out. You need to encode the error as well. So instead of failing with exception, I will be sending back a reject. So I have here my reply types. All my commands have it. And then some more validations. So in the slides, I only show that a fact I can persist. But now I'm replying back. I'm saying, okay, I got the money. Good, thank you. Withdraw. If for some reason you try to go below 0, I say that you don't have enough balance. And as you can see, I'm saying here none. There is no effect. I'm not persisting anything. I'm just rejecting, just replying that command. Here, I'm accepting it. I'm persisting the event and I'm accepting it. And here I am not persisting anything, but I'm just replying with the balance. The problem here, and that's where the enforced replies will help us, is that although this is correct code, this is incorrected and it still compiles. Because I'm returning persist returns an effect. So the effect is, the main thing is first decide if you're going to persist or not, and then I will do that. No, you do some side effects in that case, and then I will run this reply. Yeah, nice. We have typed actors, but now the compiler is not helping me solve that. This is specific for Akka persistence because it's very common that when you're dealing with persistence, that you interact with that actor, you want to know if your commands were accepted or not. So it's a very common pattern to have a reply. So can we make it better? No? So that is the enforced reply. So this is my command handler here. I will go on my behavior, and instead I will say with enforced replies. And now it's not compiling. So here it's saying that this method apply command is returning effects, but it was expecting a reply effect. So now we're gonna fix it by reply effect. Of course, the next is this one is not compiling, but that's what we want. We want to help the developer to realize that they all forget something. They said in the protocol that they want to reply, but now they have to do something. And how to do that? Now I have then reply. And the then reply receives my actor and a function. I don't know if you can see here. Can I? No. It receives a function from state to accepted. Here is the state. Or account. You see the type here is account. The type of ACC is account. So remember that my type here has the reply to. So how it works? I call this then reply. It receives a reply to. Now Akka, the Scala knows what is the type of reply to. You remember what is? Is accepted. Actor ref. So I'm passing here the actor ref, and now I need to have a function that will be used to reply here. Important is, remember that I persisted. This account is not this account here. It's the updated account. So I will persist my event. The event will be applied. I will have a new account, and now I give to you, Akka. So Akka gives to you back the updated account. Let's call it updated account. And then now you can reply. In our case here, I want to reply with accepted, so I don't need it. But you can imagine that you want to reply with the modified data, your modified model, so you have it now. And now it's compiling. Now, the next one is a little bit different because it's the one that I don't want to persist. So if I don't want to persist, I can just do reply to, and with only the reject. You see the difference here? In that first case, I did persist. And then once you call persist, you have to call, if you want to reply, you have to go this path. And you need to provide a function from the updated state to your reply. But if I just go without persisting, here, you see, directly to the reply, I will not provide a function. Because my model was not updated. I didn't persist any event, so there is no goal. So I can use here, let me show here. Yeah, reply. This is valid, because in that case here of the, let me reply, no. In the case of the get balance, it's a command that does not mutate your model. I have nothing to persist, so it's totally okay to use the balance that I have in scope here. So the API I would say it's not 100% bulletproof, because you can always, in a JVM or in a non-pure language like Scala, you can always find your way, find means to shoot yourself in the foot, but at least it's guiding you better than just like, please don't forget to reply correctly. No? So I like very much this feature, and now I have a fully typed constrained API. There is another thing that was done in Lagon, and Lagon has a typed API on top of Akka persistence untyped, and that is brought into the new API as well, and that is not available in untyped, is that when I do that here, imagine what would gonna happen if I deploy this code. Let me just close it here, so they are closer to each other. I don't have here an event handler for the deposit event, but I'm persisting here. So what can happen in Akka Typed is that you persist, and then you apply, but you don't have an event handler, and it explodes. Your actor dies, you send a new command to it, it will have to replay the events, but the events, the post is already in your journal. When you try to replay, you don't have an event handler for it, it crashes again. And you send a command, it replays and it crashes again. So we need to know that if you have defined an event handler for it or not. So what Akka, the typed version we're going to do is, before really persisting the event, it will apply the event. So because that's all in memory, it will apply the event, we'll have a state that is updated, and then, okay, now I know you have defined an event handler for it, now I'm going to persist. If it fails, because the database is down, it's not a problem. That's in memory, that actually going to die, and when you instantiate back, is as if it never happened. But if it persisted, that's it. Unless you redeploy you remove the event handler and you redeploy the application, but then, sorry guys, you choose for that. No? So it's a way to protect people from that, and I have also seen that happen. It was not me, but I have seen that happen. Good. Back to presentation mode. So that is the enforced replies. So now, one thing that have been said many times, and that message was maybe not so clear, is that persistence, we should always use that with cluster sharding. They go together very well. And the reason for that is that the Akka persistence plugin is designed, the architecture of the plugin. So any plugin out there, you can have an implementation that differs a little bit, but the idea is to provide append-only journals. Why? Because append-only on a database is much more performant than doing optimistic lock, checking the reading, and you just keep adding data at the end of the file, and so on. So it's much more performant. That's all nice if I have one node. I don't remember what I wrote here. Yeah, I come back. It's all nice if I have one node because I have one JVM. And you know when you bring an actor in memory, and if I try to, let's say that I want to send a command to account ABC. I send a command, that actor is not in memory, we bring it in memory, it receives the message, and if I want to send another message, that actor is already in memory, all those messages goes to the mailbox and they are processed one after the other, and they go to the events go to the database one after the other. Very nice. But then it's when I have one JVM. If I scale up, now I have two JVMs running in two different machines. And if my load balance send a withdraw that hit that node and another withdraw that hit that other node, now I have two representations of my account in memory where I'm taking money, checking and balance that are not consistent anymore. So I cannot let that happen. The solution for that, the most common solution is to do optimistic locking. Each time that those two go try to save something from the database, one will lose. because it's arriving too late. But then you're breaking the whole actor idea. The actor idea is to have the mailbox to serialize the commands, not to go to the database, do I/O to decide if you can do or not. So it doesn't make sense for actors to work that way. So the idea of combining persistence with cluster sharding is to, okay, the idea of Akka cluster is that to make it such that those two JVMs, they behave as if it's one JVM. And the sharding is that if my account is instantiated here, because those two JVMs making a cluster, if I have a command arriving here, it knows that the account ABC should live here, and it will forward the message to the other node. As such, I have only one account ABC in memory. ABC is the ID of the account. I don't know if I said that, but I'm saying account ABC, account ABC. So the cluster sharding will help you to create this that impression that there is only one JVM. And then comes a few features that you get from that. First is that to manage the state over the different JVMs, it knows where is your instance. So it knows where it has to forward the message for you. You don't have to deal with that. It enforces the single writer principle, so you don't need to do CAS operations, so compare and swap operations, which are costly. But because the cluster shard now is taking care of manage the memory for you, Akka needs to know when to passivate it, because usually you bring an actor in memory and you are responsible to remove it. Otherwise it stays in memory. But now is the cluster shard that will be managing where are the instances and how many they are and so on, and how they are distributed. So Akka needs to be able to say, okay, I'm not getting message on this guy here, let's shut it down. So passivation is included in cluster sharding. Important thing, and people say, I don't need cluster sharding. Yeah, probably you may not need, but there are a few things. Not only the management of the states, but also if you want to do rolling updates. Even if you have only one instance, and I have seen that happen, and again, was not me. No, I have done that. This one I'm guilty of. You put a JVM and then say, I will update my system, and you bring another one without forming a cluster. And of course, the load balancer starts to send things there while there is already something in memory now. And now I have two things. Two instances of that entity in memory corrupting my journal. So even if you are only using one JVM, if you have only one JVM, if you are not using cluster, you have to shut it down before updating it. But if you are using cluster with only one node, you can bring another node, they form a cluster. A few of the entities that are now alive here will move to the new nodes. And when you shut down, the cluster say, okay, you're going, so all the entities that were here, if there are new commands for them, will be moved to here. So you kind of swap, but you have the guarantee that at any given time there is only one instance of that entity in memory. So if you are using one single node and doing persistence, consider that, because it can save your job. There is one drawback of that, is that the commands that you send needs to be serializable. Because if you have two nodes and the load balance send a message here, and that node says, oh no, but the target of this command is living on that other node, that message will be serialized and go over the wire to the other node, and it needs to be serializable. Okay, so, but how can I put my persistence of event-sourced behavior now in a shard? No? It's very similar to what we have done so far, but there are two things that we have to add. The first thing is that, I don't know if you remember, I will go back in a while. The first thing is that because it's typed, you need to carry on the type information somewhere. And for that we have this entity type key, which is actually just holding on the type of your command, which is actually the type of an actor. The type of an actor is always the type of the message that you can send to it. If it's a general actor of an Akka persistence actor, event-sourced behavior, doesn't matter, it's always the command, the message that is sent, because it's when you talk to it. The reply is in the message itself, and the events, it's internal, you don't see from outside, and the state as well. So this type key carries on an identifier, account, and the type. But because the events, once you shard it, is Akka that will be instantiating things for you. You need to give enough context for Akka to instantiate it. So instead of just passing the account behavior or the account ID like I did here, you see here, the behavior, it's getting just an ID of a string. Instead, I have to pass an entity context, because who will be calling that behavior method? It's not you anymore, but it's Akka. Okay? And it has to carry on a little bit more context to be able to instantiate your event source behavior. So that entity context has a name. You remember here I put the persistence ID in the previous example, has like account and the ID. Now I will have it in the name. That name here that we see is the account here. Is that name, the same. You can use another one, but it's a good practice to keep that synchronized. And the ID. The ID, we're going to see later how this ID is. The rest is exactly the same. So you define now, instead of behavior getting a string, you have a behavior getting an entity context for your type, account command. Okay? That's it. Well, not all. You need to tell Akka that this thing exists. So you're going to take the cluster sharding extension and say, init that thing, I want an entity. That's the type key. You remember I put the type here in the companion object account, type key. I'm just using it here. And now a function that will go from the context to the behavior. And I tell, okay, whenever someone asks for an account for entity for this type key, that's the function that you have to use to instantiate it, this one here. When we do init in a cluster sharding, we are not instantiating the entities. I don't know the ID. I don't know yet how they will look like. What we do here is we create the shard regions. We prepare the distribution in the cluster. Okay? They are not instantiated. They get instantiated when you request one instance for that, which you do by asking the cluster sharding, okay, give me an entity ref for that type key and that account number, which is the second hint. So a difference here is that you don't get an actor ref, you get an entity ref. And the goal here is to, well, it's like an actor ref, but it's distributed. It can be on the node where you're calling it, or it can be in another one. So, and that's a cool thing. And it has the ask method, for instance, like you have in the actor ref, but it's built in. You don't need to extend it with a pattern, it's just there. And why is that all important? I think that Akka persistence type is super cool to have it now. Not only the Akka typed, it's a huge game changer for all of us using Akka. Akka persistence type is very on the rails, like protecting people to do, guiding people to do the right thing. Whenever you have a declarative API, it's always a win. If you're coding in Scala, I think that everybody have learned a little bit about the advantage of that. The difference also compared to the untyped one is that here you concentrate on your modeling. You concentrate on the commands and the events, your protocol, the command handlers, the event handlers, your state, and not the machinery. You don't need to think how that thing, it's interesting to know how the machinery works, but you don't need to build the machinery yourself. Because if you think about that, the use case is very limited, it's very well defined. A command comes in, you validate it, you decide if it can produce event, yes or not. The events are persisted, the events are applied, ready for the next command. That machinery, event sourcing, it's always the same. So it's better to get it right and not have to rethink it each time. Types everywhere, that's cool, functions everywhere. And the joke is that people were complaining about Akka was a function from any 2 unit run asynchronously. Well, it's part of the past. If someone comes to tell me that Akka is just a function from any 2 units, I give a hug because I understand the pain, but it's past. You don't need to. So if tomorrow you start a new project using Akka, just go Akka Typed and Akka Persistence Typed. But those are more library, API kind of takeaways. But there is also one important thing. It's what event sourcing gives to you. And we talk a lot about microservice. And if you think about building microservice without event sourcing, that means that you are building service A, service B, and service A needs service B. It means that service A is calling service B. Blocking calls. If service B is down, service A is either broken or downgraded to some partially functioning application. And when you are able to represent your change, your data in terms of events, now you can propagate that data, put it in a broker at some point, and the other system can consume from that broker and make decisions while watching to your change. So this allows for decoupling. So I can bring my service B down, and service A is still functioning because it doesn't depend on me. It depends on my broker, my topic. Is event consistent? It is, but it's always event consistent. Even when you are calling each other, it's event consistent, because while I'm fetching data on that service here, there is someone already changed that data. I always see a data that is potentially out of date. So so event sourcing helps you decoupling, and Akka Persistence Type helps you to build event-sourced applications. As I was saying, append-only journal is important. Other libraries that build event-sourced do optimistic locking. It's okay. In many cases, that's more than enough, but not always the case. So for the JDBC plugin, for instance, so all the existing plugins for Akka Persistence, they are doing append-only journals. But for the JDBC, I'm not saying that we're going to do that. For the JDBC plugin, it can be potentially something. It could be you could do optimistic locking. I'm not saying that we want to do that, but depending on the database, it's possible. And for some case, this is good enough. But we prefer to have one clear message: is append-only journal everywhere. Cluster sharding gives you scalability, but also reliability when you're doing, especially when you're doing append-only journals, rolling updates, as I was explaining. And there is one thing which is distributed event consuming. And how much time I have? Time is up. Okay, I will wrap up. But where is Emmanuel? He's already here. Someone told me that I could talk forever today. So one thing about distributed event consuming is that when you consume your journal, all those events goes to the same journal, and you create a query to consume it. But if you put it naively in your application and you scale up to 3 nodes, now you have 3 nodes consume those events. But you only want to consume it because they will consume the same thing and produce the same things. So the naive solution is to put it on a cluster singleton. And a cluster singleton, there is only one in the whole cluster. But then it's a bottleneck. All the events have to go through that cluster singleton. So what Lagon does is there is a technique to create a distributed consumption of the event journal. And that's something that either we're going to extract or we're going to write more and explain people how to do that. And hopefully I send a talk to Scaladace to explain how that works internally. Hopefully it gets approved and you guys can, otherwise I come back to Rotterdam. Good, I will stop talking. Thank you very much. And the code is on my GitHub, Akka Persistence Typed talk. And yeah, you can reach me on Twitter. Thank you very much.